Hi guys. As promised, I'm about to record you a video for in-class advanced SQL exercises. Those are examples for our advanced SQL lectures that will cover joins, different types of joins, subqueries, different types of subqueries, and at the end we're gonna cover union and specifically case statement. Before we start, before you watch this lecture, please make sure that you review the slides for advanced SQL theoretical material. Make sure that you understand what type of joins exist. You need to understand equi versus non-equi joins. You need to understand inner joins, outer joins, right outer joins, left outer joins, full outer join. So you need to understand what type of joins we learned. Also, you need to know what is subquery. There's a difference between correlated and non-correlated subquery, and you need to have a very good understanding what statement exists and all means. As well as understand the concept of union statement and the case statement. That's what we will be covering during today's class. All right, so let's start. I want to have two, let's see, okay. Just a second, I'm trying to make sure that my screen works. All right, so um, I have on my screen this presentation, and let me open SQLite Studio. So for SQLite Studio, as you guys remember, every time you open it, if you don't already have that set up, you need to make sure that you see the database window, and it's also very helpful to see the status window. Status windows is where you can see the result of your query execution. It's right here. All right, so let's connect to Chinook database, and I have mine on desktop. The database, and they're all set. Okay, so again, this is those are in-class exercises for advanced SQL module. So we're gonna start from the first example, and they're asking us to write a query that returns the album name of tracks from metal genre, and they want us to use a subquery. So first of all, we need to decide what table we are going to use for this query. Well, potential tables are probably tracks because they're talking about track here, right? Tracks. And another potential example is genre. So let's look at those both tables and see what table works better for us. So genre has a genre ID and genre name. It doesn't have anything related to trucks. Let's see what trucks table have. And again, like when you need to decide what table to use, the first step for you would be to look at the data model if you don't know the schema really good. So the way you look at the usually databases that we use in class and for homework have schema for those. So for example, in this case for SQLite database, we have schema here. So Well, let's look at the schema in more detail. So we have a tracks, and this is an entity relationship diagram for this schema, but it's complete, so we can use it for the query design. So let's look at the tracks entity or table in our case. So it has track ID, name, album ID, and so forth. It also has genre ID. Well, the problem is we need genre name, but this table tracks doesn't have a genre name. What has genre name is a table genres. As we can see here, genres connected to tracks and via primary key and foreign key. And the foreign key sits on the many side of relationship, which is tracks in this case, and one side of relationship holds primary key. In this case, that would be genre. So genre ID is a foreign key for genre tables in tracks table. Right. So we have a very basic idea on where to start. Let's and they want us to use subquery. So the way we're going to use subquery is we need a genre name, right? So we need genre name metal, but our trucks table doesn't have genre name. And we just looked at genre table, and genre does have name. So um, the way I'm going to design this query is I'm going to start from subquery. I'm going to select the genre ID from genre table where name is equal to metal. And then I'm going to use the genre ID to find all album names from tracks table. So there's two ways of doing it. Well, you can start from genre, for example, and you can go select everything, and then you can modify this query, or you can start from tools, open the SQL editor and from scratch, because I mean it doesn't really matter. We're going to be using multiple tables, so I mean you can have a pre-created query, but it's not going to save us much time. So let's find the genre ID. Let's create our subquery first and make sure that it executes. Again, in subquery, we are trying to find genre ID from genres where name is equal to metal. So let's start. Select genres. Mm, And we're going to search it out. Oh, interesting. Okay, here we go. Genre, no, genre dot ID from genre G, where G dot genre name equal to Mac. Let's see if it executes. All right, very cool. So we found genre ID for name metal, and now we can use the genre ID to find all genre or all album names from tracks. So let's look at the tracks table. Let's see what column we will be looking for. And well, it's probably going to be name. So let's start our outer query. So select from trucks B. That it doesn't work. Okay. T there T dot track genre ID, because we already know that this outer query returns genre ID. So T dot D equal to, and then we have our subquery here. Just need to fix my syntax a little bit, and we will be selecting track names, so or album names. In this case, it's going to be name field, so it's going to be t dot. Okay, so let's see if that will work, and here you go. So we have 374 records here. Well, you can make it pretty if you want. You can click this button and it's going to be pretty. So that's the result for the first query, and see that we did it correctly. So we have 374 records. All right, so let's start with the next one. Next one states that you need to write a query that returns first name and last name and the total balance for each customer. Again, same dilemma. And the hint says check during examples, during lecture examples, you need to use aggregate function sum total as balance and group by clause. All right, well, first of all, let's think what table holds first name and last name of the customer. Well, let's look at the diagram. So here we have customer table, and customer has first name and last name. And we also need to find the table that holds total. Unfortunately, you don't see the full invoices here, but I assure you that that would be an invoice table that holds total. So invoice columns. As you can see, total is here. So now we need to get information from two tables, right? So we need to join them. Well, first table would be customers, where we'll be getting first and last name. And from invoices, we will be getting total balance. And total is a column in invoices, and first name and last name are columns in customers table. Right, so let's see a diagram again. So invoices has a relationship with the customer table, and invoices is a many-sided relationship, and customers is one-sided relationship. So in this case, we need to find what is a foreign key and what is a primary key in this case. In this case, it's going to be primary key will be on the customer side table, because again, this is a one-sided relationship. And foreign key will be on invoices side. So that would be obviously the same field, customer ID, and we need to join two tables for our query. So let's start from let's select asterisk for now, and then we will decide what fields we will need to select. So select asterisk from customers. And in this case, we can use inner join, we can use equijoin. So I'm going to be using equijoin, but you can use inner join again. Syntax is going to be a little different from equijoin and inner join, but the idea is the same. So, and since this specific example doesn't tell us what exact statement to use, I can use whatever I'm more comfortable with and whatever works for me. So I decided that I will be using equijoin. So in equijoin, I need to list tables in the from clause. So we're also going to give them aliases for simplicity, so we can use IntelliSense later on. So we'll be selecting from customers. Customer C, invoices I, there, and since it's equijoin, we will be putting a condition for join in the where clause, where customer ID is equal to invoice customer ID. Very good. So let's stop right here. Let's test. All right, so our query gives us results. Clearly, it's a lot of duplication, but again, what I really care at this point if my initial query works. All right, so now we need to use sum of total, right? Because that would be total for customer. And as we know, invoices is a many side of relationship. So in this case, one customer can place many invoices. So let's select I dot total. And we are going to get sum of total. Sum of I total, and we also need last name and first name. So those would be coming from customers table. So customers first name, customers last name. All right. And since we're using aggregate function, we need to group by customers. So in this case, we are going to use group by and we're looking for aggregates per customer, so we will need to group per same customer. So we'll be using group by, and in this case, you can group by first name that last name, um, or last name first. Not customer ID. See that first name, and that should be it. So. Um, and again, like, I mean, the reason why we're grouping for first name, last name, because we need to have a total per customer, and those are the fields that we're using in addition to aggregate function and select statement. So let's see if that works. Right, so we have an error here, and it says error while executing near C. Let's see what I'm doing wrong. C dot last name. See that first name. Um, And see, guys, I want to show you a little bit how to troubleshoot queries. So I know exactly where my mistake is, but I'm going to try to comment some areas to see if I can get to my mistake. So, all right, so this query executes. Now, let's see what's going to happen if I'm going to uncomment the first one. Again, this is a very basic troubleshooting that you guys can easily use for when you write your queries. Okay, perfect. So that works. All right. So then most likely the error is in my last statement. All right. So I don't know what went wrong, but I mean this query executes. So let's see. Let's see what we have in the next result set. We have 59 records. Another way to, well, first of all, you can, when you select some data from a table, and in this case, you select multiple fields from customer table. So say first name and last name. You can group by combination of first name and last name, or you can group by primary key for this table. So if you're gonna group by primary key for this table and execute, we're gonna get the same exact number of records. So because grouping by a group of fields from a table or grouping by primary keys pretty much gives you the same results. All right. Another way to write this query is using inner join. So to use inner join, we will select from customers. And as we remember from the slides, inner join returns us only data that has matches in two tables based on primary key, foreign key relationships. So we're going to rewrite this using inner join just for an example. So let's select from customers, inner join inner join invoices on see that customer ID invoice equal to invoice customer ID, and that should return us exactly the same number of rows because it's just a different way of joining two tables. All right, cool. So moving on, next example is a little more complicated. We are going to use exists operator to display invoice ID and invoice date for all the invoices that have a row in invoice item table. So in this case, and we need to use correlated subquery. And as we remember from the lecture, Advanced SQL lecture, the difference between correlated subqueries, query and correlated subquery is the fact that non-correlated subquery executes only once for the entire execution of outer query, and correlated subquery executes for every row. So that is why correlated subquery has a link to an outer subquery. So let's start first from identifying the tables, but that here it's very clear. We need to display invoice ID and invoice date for all the invoices. Well, sure enough, invoice ID and date, they're part of the invoice table. And they also want us to display only those invoices that have that have items, that have a record invoice item table. Let's look at the diagram of the database and see how invoice and invoice items are connected in ERD. So as you can see that invoices sits on one side of relationship and invoice item sits on many sides of relationships. So we remember that foreign key lays down on the many side of relationship and primary key on one. So primary key will be invoice ID and foreign in invoice table, and foreign key will be invoice ID in invoices table. So in this case, we are using correlated subqueries. So we're gonna start from selecting invoice date and invoice ID from the invoices table. And then we will use, we will write a subquery. So let's select asterisk from invoices I, I, and we need to select I dot invoice ID, I dot invoice date from invoices now. We need to use exist statement. So exist statement, as you remember from lecture, usually used in where clause. So where exists exists, and now we need to write inner a query as a subquery, and so when we're using exists, if you guys as you guys probably remember from the lecture, exists compares, it's a Boolean operator. So if inner query or subquery returns any data, exists will return true, and the outer query will execute. So we can, in this case, we just need to see if a specific record for invoice item exists. So we can select asterisk or select primary key. It doesn't really matter. So select, for simplicity, I'm going to select everything. Select asterisk from invoice items. I think I spelled it correctly. Okay. Invoice items. Invoice items. I think I spelled it correctly. Now, In very close, we will need to combine our outer query table with invoice items, which would be invoice to invoice items. And just like we looked at the diagram, we can join them based on invoice ID. So where I dot invoice ID equal to other invoice, right? So let's execute it. And here it goes. So we have invoices that have items here, and it's total of 412 records. Let's see if it's correct. All right, looks good. Okay, so again, when we're using exist statement, it is a Boolean operator. As a result of exist statement is a Boolean operator. So if the item, if we have a record that matches the condition specified in very close in the subquery, our outer query will return results. Okay. Next one is write a query that returns the name of the longest and shortest track. Use union. Okay, so well, first of all, we need to understand what is the track length. Well, it's clearly part of the tracks table, right? Because it says the name of the longest and shortest track. So let's see what can potentially give us the size of the track. Well, let's look at the data in tracks just to see what can potentially be the case for us. So the data looks like, right, here you go. So most likely it's going to be the length of the track is going to be in milliseconds, well, just based on the common sense and bias, it will be the size of the track. So we need to find the shortest track in milliseconds. So we need to find min millisecond from tracks table, and we need to combine it. And we probably want to return the track ID with that or track name. And then we're gonna do exactly the same query, but we'll return max. So let's do min first. Min milliseconds from tracks, and in addition, let's return track name. All right, so min track has this name. Now, we need to also return the max. And we're gonna use union for this, and we're gonna copy exactly the same table and just replace min with max function. Okay. Let's see if separate max works. Awesome, it works. So now let's see everything else works. Okay, cool. We can order it by name or by min or max, so it doesn't really matter. So you can order by name if you want, or you can order by the second parameter. Remember, in at some point in class we looked that you can number those number parameters in the select statement by 1, 2, or so forth. So instead of ordering by name, you can order by 1, or you can order by second parameter. In this case, they're going to be order descending. Important, and we can beautify it if you want. So important for unions, you need to make sure that you have exactly the same number of columns and exactly the same data type for in both queries that are used in union. All right. So let's check our result set. So we have two, obviously, same data here. Uh, Different order, but it doesn't matter. All right, so let's go to the next one. So how much money did customer 15 spend on different genres? Um, so, um, well, first of all, what tables we're going to be using? Well, we know that genre, the tracks has genre ID. We also have a genre table that has genre, but we are looking for total. And we can either use total in invoices, or we can get unit price and quantity from invoice items table. So there's two ways of doing it. Um, let's start from we can get again, like we can get this data from invoices. Or you can we can get this data from invoice items. So let's start writing a query. So I would assume we need to combine three different tables. We need to combine invoices with invoice items. With potentially, well, let's see if we can eliminate invoice items. So let's see if we can only work with invoices. Well, invoices doesn't have a link to genres. Um, it doesn't have genre ID, it doesn't have track ID. Track ID has genre ID. So the easiest way for us would be to, and we need to get customer information. So if we wouldn't need a customer information, we can probably just join invoice items with tracks based on track ID, and then we can join track to genre on genre ID, and we can get our data. The problem is we also need customer information. So since we need customer information, we need customer ID. We need to join to customer table too. Or we need to join to invoice table too and search for customer ID equal to 15. All right, so it's many tables. So let's start from writing the basic select everything, select asterisk, and then we will identify what we need. We will use four tables. Again, we can use equijoin or we can use inner join. So I'm going to use inner join because last time we used equijoin, but then I'm going to show you how to write it using equijoin too. So let's start from invoice. It doesn't really matter what table you start from joining. You just need to make sure that you include all the tables. So let's start from invoice items. Um, inner join invoices. Um, inner too many ends. Inner join invoices. Um, on inner join invoices on I dot invoice ID equal to I dot invoice ID. Awesome. So let's execute this part. Cool. We get some data. So now let's join to let's join to tracks to get genre ID. And how we join tracks An invoice item is, we need to find, well, first of all, the easiest way would be to look at the diagram and see how tracks and invoice items are related. So as we can see, invoice items has track ID and it's many side of relationships. So there is a foreign key track ID here, and tracks has a primary key. It's one side of relationships that would be track ID. So we join them on track ID. Where's my lecture? Okay. So let's join inner join tracks. Inner join tracks. T on on track ID equal to T dot track ID. Awesome. So let's see if we can execute that. Very good. So the only other item, the only other table we need is genres, because we need to know the genre name. Genre IDs is not gonna, okay, that was by mistake. So, and last table would be genres. Track dot genre ID equal to genre ID. Right, let's execute that. Okay, so we get some data. Now, we need to, we have a condition. We need to get this data for customer ID 15. So we're gonna write there um, uh, invoice dot customer ID equal 15, and then let's see if that executes. All right, so that works. The only last thing we need to get how much money customer 15 spends on each genre. So we need to get a combination of quantity and unit price from invoice item, and that would be the total price, that total amount of money that customer spent, and then we need to aggregate it by customers. So let's get some of invoice item to be to be the name of the field. So invoice item unit price, but invoice unit price. As you can see, sometimes IntelliSense works, sometimes it doesn't. Unit price multiplied by quantity. Okay. And we're gonna call it, we're gonna give it an alias as um, amount per genre. And then we also probably need to select genre names. So genre names comes from genre. And the only thing we are missing here is, as we remember, when we use an aggregate function, we need to have a group by. And in this case, we are grouping by genre. So we can group by genre ID or genre name. So we can add group by G dot genre name, and that should work. All right, so we have total per genre here. It's a little long query. Let's see if we get the correct data. Yes, eight records. We have 8 records. We can sort it by. We can order by this field just to make it a little look a little better, right? And we can beautified here. So, all right. So here is our query. The same exact query you can write using equijoin. So again, as we remember, in equijoin we just list the invoices. I'm lazy. I'm just gonna copy paste. Then trucks. Then and then all the oh, and genres. Got genres, right? Yes. Um, and all the conditions will go to very close. So control X there, and another condition is gonna go to very close. Okay. Dot general. And and we also need to eliminate it all from here. So here's our final query, and that should give us the same exact result. Again, it doesn't really matter what you guys want to use. Equijoin, inner join doesn't really matter. Again, unless I ask you in the exam to use one or another. We can make it a little prettier if we can use this T button to beautify it. So here's our final query. All right. So the next one is how much money did each customer, same one. All right. So next one is going to be how much money did each customer spend on each genre. So this one is pretty much the same as the query that we wrote here. We just need to add customer name here. We can add customer ID, and that would do. So we are going to remove customer ID from here, and we are going to remove customer ID from here. So this is pretty much modification of the existing queries. So we're gonna use customer ID as in a selection, and then we will group by genre, and we are going to group by customer ID. So invoice dot customer ID. And I think that's it. So let's execute this, see if we get any data. Come on. Right, so no such column. It's C dot customer ID. Oh, of course, there's no such column because that's a wrong table. Right. So that should do. We have amount per genres, customer ID, so we can maybe order it by quantity, and customer ID we can order it by two fields. That would do too. See, all right, so that should give us quantity per genres. So 440 records, 438 records. Close enough. Okay, so that is the way to write advanced SQL to join tables. Again, please practice. SQL is just like any programming language require practices. And thank you for listening. And happy SQL coding.